In our lesson today, we're going to continue looking at ratios, rates, and unit rates. In our first example, they tell us that in a basketball contest, Elizabeth made 9 out of 25 free throw attempts. Alex made 8 out of 20 free throw attempts. Janie said that Elizabeth had a better free throw record because she made more free throws than Alex. Do you agree with Janie's reasoning? Show work and explain. Okay, so first thing I noticed right away is that Elizabeth and Alex here didn't have the same number of attempts. So I'm already a little cautious of what Janie's saying here. Janie said again that Elizabeth did better because she made more free throws, but they didn't have the same number of attempts. So I'm not going to agree necessarily with what Janie has said because of that, but maybe Elizabeth still did better. Let's see if we can figure that out. So I'm going to, for Elizabeth and Alex, I'm going to make a table of values. So let me get my names on here, Elizabeth and Alex. And I'll start with Elizabeth, where we're looking at the shots made out of the attempts that were made. And we were told that Elizabeth made 9 out of 25 attempts, while for Alex, again, this is the shots made out of the attempts. Alex made 8 out of 20 attempts. So again, it's not out of the same number of attempts, so I can't simply compare the shots that were made. What I'm going to have to do is get these numbers so that they're out of the same number of attempts. And so looking at 25 and 20, what I'm actually going to do is look for the least common multiple for 25 and 20. And if I think about that enough, 25 and 20, their least common multiple would be 100. So I'm going to scale up from 25 attempts and from 20 attempts up to 100 attempts. The question is, how will I do that scaling up? Well, to go from 25 attempts to 100 attempts, I'm going to have to multiply by 4. And to go from 9 times 4, I'm going to have to get 36 shots that were made. Since I scaled up by 4 with the attempts, I scale up by 4 with the shots made. 9 times 4 is 36. So I would think that Elizabeth would get 36 out of 100 shots that she attempted. For Alex, to scale up from 20 attempts to 100 attempts, I'm going to multiply by 5. Do the same thing to the shots made. 8 times 5, I would expect that Alex would make 40 out of her 100 attempts. And so now looking at these numbers, because they are out of the same number of attempts, I can see, well, Alex has done slightly better than Elizabeth has. And if I think about this carefully enough, I've made these out of 100, which means I can actually relate these numbers to percentages because a percent means out of 100. Elizabeth, I would say Elizabeth made 36% of her shots, while Alex here, 40 out of 100, Alex has made 40% of her shots. So I don't agree with Janie, and I'm going to say that Alex did better because she made 40% of her shots, but Elizabeth only made 36% of her shots. So again, I'm only able to compare these numbers when they're out of the same number of attempts. So I scaled ahead to their least common multiple of 100, and that allowed me to see that Alex actually did better than Elizabeth. In example 1, we're told that Nathan and Dan were both hired as lifeguards for the summer. They received their paychecks for the first week. I want to know who earns more per hour. So here we have Nathan Smith. Nathan worked for 5 hours and earned $46.25. And then we have Dan Jones, who worked for 9 hours and earned $78.75. So again, I want to know who earns more per hour. So what I'm going to do for each person is, again, make a ratio table. So let's start with Nate. All right, so for Nate, I'm going to be interested in knowing how many dollars he earns per hour. Dollars per hour. I know right now off the bat that Nate made $46.25 for working 5 hours. And I want to know how much is he going to make in 1 hour. So to scale back from 5 hours to 1 hour, we'll just divide by 5. We'll do the same thing with our $46.25. And if you do 46 and 25 hundredths divided by 5, that gives you 9 and 25 hundredths, which means that Nate makes $9.25 per hour. Okay? We'll do a similar approach now for Dan. And again, in our table, we're going to have how much he makes 2 hours. And we were told that Dan makes $78.75 in 9 hours. To figure out how much Dan earns in 1 hour, we're going to scale back by dividing by 9. 9 divided by 9 is 1. 78 and 75 hundredths, if you divide that by 9, you're going to end up with 8 and 75 hundredths, which means that Dan makes $8.75 per hour. So I now can see that Dan earns $8.75 per hour. Nate makes $9.25 per hour. Nate earns more per hour. I'm always interested to know by how much more. So what I would have to do is take these numbers and subtract them. And if you did $9.25 per hour minus $8.75 per hour, that's going to be a difference of 50 cents per hour. So I can say that Nate makes 50 cents per hour more than Dan. Nate makes 50 cents per hour more than Dan. Now for our try it example, Jennifer is a lifeguard at the same pool. She earns $137.25 for 15 hours of lifeguarding. How much does she earn per hour? So we're going to have a similar setup here where we're going to make our ratio table in dollars to hours. And we know that Jennifer earns $137.25 in 15 hours. We want to know in 1 hour, how much does she make? So we'll simply scale back by dividing by 15. 15 divided by 15 is equal to 1. $137.25 divided by 15 is going to give us 9 and 15 hundredths, which means then that Jennifer earns $9.15 per hour. Okay, so now we know how much all 3 lifeguards make. Jennifer earns $9.15 per hour. In example 2, we're told that Brian agrees to watch his neighbor's dogs for 7 days. His neighbor provided a 128-ounce bag of dog food, and I want to know, does Brian have enough food to feed the dogs all 7 days? So we can see the 2 dogs here. We see Buster and Roxy, and we're told that Buster will eat 20 and a half ounces of food in 2 days, while Roxy will eat 22 and a half ounces of food in 3 days. I want to know, if we have a 128-ounce bag of food, will that be enough for all 7 days? So what we're going to do is create a table for each dog to figure out how much food they need in 1 day, and then ultimately figure out, do they have enough food for 7 days to be with Brian? So let's start with Buster. Okay, so again, here we're going to be looking at the number of ounces per day. Ounces per day is what we're looking at. They tell us that Buster has 20 and a half ounces of food in 2 days. We want to know how much food does Buster need each day, so we will divide 2 days by 2 to get to our 1 day. And if we do 20 and a half divided by 2, we get 10 and 25 hundredths. So Buster needs 10 and 25 hundredths ounces of food per day. Well, what about with Roxy? For Roxy, again, ounces to days, and we're told that Roxy needs 22 and a half ounces of food in 3 days. We have to figure out how much food Roxy needs in just 1 day. All right, so this time we're going to have to scale back by dividing by 3. 3 divided by 3 is our 1 day. 22 and a half divided by 3, well, that's going to be 7 and 5/10, or 7 and a half. Roxy needs 7 and a half ounces of food in 1 day. At this point, we have a couple of different options that we can use to figure out if we have enough food for all 7 days. One thing that I could do for each dog is actually in my table add another column where I'm going to extend ahead. for 7 days. Okay, which means for each of my dogs, I'm going to have to multiply 1 day by 7 to get to 7 days. So I'm going to have to take the number of ounces they need in 1 day and multiply those by 7. If you do 10 and 25 hundredths times 7, that means that Buster needs 71 and 75 hundredths ounces of food in 7 days. Do the same thing now for Buster. If you do 7.5 times 7, or excuse me, for Roxy, Roxy needs 52.5 ounces of food in 7 days. And now the next thing that you can do is just add up these numbers. 71 and 75 hundredths plus 52 and 5 tenths gets us to 124 and 25 hundredths ounces of food. Combined, the dogs need 124 and 25 hundredths ounces of food in 7 days. The bag was 128 ounces, so yes, Brian will have enough food. That was one method. The second method that you could have done, you could have stopped right here at their unit rates. Buster needs 10 and 25 hundredths ounces of food per day. Roxy needs 7.5 ounces of food per day. I can add these numbers right here. 10 and 25 hundredths plus 7 and 5 tenths is 17 and 75 hundredths ounces. That's how many ounces of food they need per day. So then I could just take this number, multiply it by 7, and that's still going to give me 124 and 25 hundredths ounces of food that they need in 7 days. Either way, we get the same answer. So we can say that Brian does have enough food for 7 days. Brian does have enough food for 7 days. All right, so Buster and Roxy will not go hungry while they're staying with Brian. In our final example, we're told that a kitchen sink faucet streams half a gallon of water in 10 seconds, and a bathroom sink faucet streams 75 hundredths of a gallon of water in 18 seconds. Which faucet will fill a 3-gallon container faster? Will it be the kitchen sink faucet or the bathroom sink faucet? So just like I've done with my other questions, I'm going to create ratio tables. So we're going to have the kitchen here, we'll have the bathroom here, and they've told us how many gallons they can sink in 10 seconds and in 18 seconds. But the ultimate goal is to figure out how much or how long will it take to fill a 3-gallon container. So we're actually going to be scaling by our gallons in this example. So for my tables, I'm going to do seconds to gallons. Seconds to gallons. All right, so let's see if we can figure out which one will fill the bucket faster. For the kitchen sink, it says that it can do a half a gallon in 10 seconds. I think it would be useful to know how long it would take to fill up 1 full gallon. To go from a half a gallon up to 1 full gallon, well, all you have to do is multiply by 2. A half times 2 is 1. Do the same thing to your seconds, 10 times 2. It will take 20 seconds for the kitchen sink faucet to fill 1 gallon. Now we can easily scale ahead to the 3-gallon container if we multiply by 3. 1 times 3 is 3. 20 times 3 is 60. So it will take the kitchen sink faucet 60 seconds or a minute to fill that 3-gallon container. How does that compare to the bathroom sink? Well, for the bathroom sink, they told us that it was 75 hundredths of a gallon that it can fill, and it would do that in 18 seconds. 18 seconds for 75 hundredths of a gallon. Again, let's figure out how long it would take to fill up 1 full gallon. So I'm going to have to divide by 75 hundredths. 75 hundredths divided by itself is 1. 18 divided by 75 hundredths, if we punch that into our calculator, that's going to give us 24. It takes 24 seconds for the bathroom sink to fill it up 1 gallon. And now if we scale ahead to the 3-gallon container times 3, 24 times 3 is 72. So the kitchen sink can do it in 60 seconds. The bathroom sink can do it in 72 seconds. That means the kitchen sink is faster. The kitchen sink fills a 3-gallon container 12 seconds faster than the bathroom sink faucet. Okay, if you do 72 minus 60, the kitchen sink will fill it 12 seconds faster than the bathroom sink will. So again, set up your ratio tables, fill in your given information. You can scale back to your unit rate, and then you can scale ahead in order to answer your question.